Hello, welcome to another Midnight Maths video. Today we're going to be introducing the concept of the first derivative test so that in another video we can solve an AP style problem with it. So before I introduce this idea, I'd like to talk about what exactly people mean when they say a sign chart, because really the heart and soul of this optimization stuff is really going to come from this idea of sign charts. And so what sign charts are is, suppose you want to find the sign of a function g along a given interval. And so first, you might want to solve for the equation g of x equals 0. Or you also might want to find where g is not defined either. And so after you do that, you'll get a few values of x. And what you'll do from there is typically you make a number line. Maybe these are certain values of x that you got that when you plug them into g, they give you 0. And then afterwards, in each of these little subintervals that you've created, right, you will try different values. So maybe you'll try a value that's in here. And then if g is positive there, then you'll put a plus sign, and that means that g is actually positive throughout the entire interval between, in this case, c and b. And so you'll do that for maybe some other intervals, and it might look like this. And so you'll get a general picture of what the sign of g is over pretty much the entire number line. And again, the key point here is that if you try one value in this interval, because you found all the zeros of g already, you can safely say that g is going to have the same sign all throughout that interval. And that's probably the thing that's fundamental to sign charts that you'll be using. Now, with sign charts, one function that we're particularly interested in is the function f prime. Now, the sign of f prime can tell you information about the maxima, local maxima or minima, and you might also hear the phrase extrema, local maxima or minima of f. So basically, if you want to find the local extrema of a function, then you can look at the sign of its derivative. Now this is kind of thematic with our last video where we talked about several graphical interpretations of the derivative, and you'll see that the lessons that we learned from the last video will also play a part here. Now, the real nuts and bolts of this idea and why it works is IVT, a special case of IVT called Rolle's theorem. I'm not going to go over that here, but it's a good exercise if you want to see why this all works. But what I'm really going to go over here is what the sign of f prime tells you about f, and more specifically changes in the sign of f prime. So let's take a look at that. So I'm going to draw three canonical examples here that will sort of suffice to illustrate the point. So here, right, this is, we'll go over what these points are in a second, but let's take this graph right here, right? Now, on the left side of this point, you can see that the first derivative is clearly positive, right? Our function is increasing. And then we get to this point, and then our function decreases. The first derivative is negative, right? Now, this point, we say, is a relative maximum, right? And so what you can see here is that if the first derivative is 0, then there is a chance for the function to be a relative maximum at that point. Likewise over here, we can see kind of an analogous thing, except this time we're decreasing and then increasing. And right here, we've got a derivative of 0. Now, one important thing is that the derivative doesn't necessarily have to exist at the maximum. right here, you can see it's basically the parabola that I drew underneath here, but there's just a sharp point here, and so the derivative doesn't exist, but it's still a relative maximum. Now over here, this graph, you can see that the derivative is always negative, right? So as we'd expect, there's not really any relative extrema on this interval that I've drawn. So we can sum all this up in what we call the critical points of f. And what the critical points are basically whenever the first derivative is either 0 or it doesn't exist. At these values of x, you might have a relative maximum or a relative minimum. If, for example, right here, there are no critical points on this interval that I've drawn, so there will be no relative extrema there. And this critical point idea, we will use the idea of a sign chart to properly use the idea of critical points, right? And this is really, once you combine the sign chart with critical points, is where you get the first derivative test. Because what the first derivative test says is that if f prime changes from positive to negative, that would look something like this, then you've got a relative maximum. But if f prime goes from negative to positive, then you've got a relative minimum. And that would look something like this. And if the sign of f prime doesn't change, then it cannot be not a relative minimum or maximum. Now keep in mind that we've been dealing with relative extrema up until this point, and absolute extrema may not be caught inside the first derivative test, so just keep that in mind. But this here is basically how you would use the first derivative test in practice. You would use the idea of a sign chart, you'd find the critical points of f first, right? Then you'd create a sign chart of f prime, right? And then afterwards, you'd use that information that you got from the sign chart to make conclusions about the function f. Now, why mention sign charts as a separate idea? Well, you can use sign charts not just for maximizing, say, f, but for example, if you wanted to know the sign of f double prime over an interval, then you could do that. And there are questions that'll ask you about the sign of f double prime or some other random function that's not f prime. And so it's important that you get the idea that sign charts are a more general thing that you can do with pretty much any function you want. But critical points and the first derivative test is a specific application of the idea of sign charts in order to maximize a certain function. That'll be it for this video. In the next one, we'll be talking about a specific AP example about the first derivative test, and so that you can really see how this is used in practice. Hope you enjoyed this one, and I'll see you guys in the next one.